Okay, so now that we've learned a little bit about vectors and hopefully you brushed up at the Khan Academy to get used to these things, and I've introduced what I want to accomplish, let's code these up so we can use them in our game. I'm going to use a test-driven development approach. If you're new to testing, no big deal. If you already have opinions on testing, that's fine. Why am I using test-driven development? The idea is we write a little test to test what we're trying to accomplish. We see that the test fails. We go and we implement the code to make the test pass, and then we just drive our development that way. That's why it's called test-driven development. A lot of people think test-driven development is you write all the tests up front, and well, how am I going to test a whole ton of code that I don't even know I'm going to write? So no, you don't write all the tests up front. We know what we're about to accomplish. Let's test for it, make it happen, and then pass the test, kind of thing. So I went and found googletest, a really sweet little testing lightweight framework. You gotta kind of get used to the syntax. They're pretty macro heavy. I pulled them down. I added their Google test here to my repository under the middleware section. It's kind of middleware. It's not. It's a tool we're going to use, and we're only going to use it in testing. Why am I testing? There's benefits and cons. The benefits are, hey, if you have a ton of tests speeding up your code, whenever you go change something, then you can feel good that if all the tests pass and you're a very good tester and you test all the intricacies, then you can feel good that your test is good. But if you fail a test immediately, you're in context. At that point, you know in your mind, oh, I just changed this. This isn't going to work, so I got to go back and fix that. All right, so if you make a change in your code and you don't have unit tests, and you find out that you have a bug in that code 2 or 3 weeks later, it could cost you debugging time. You come back, you're like, oh yeah, I forgot I changed that code about a week or two ago, and I just lost a half hour of my life trying to find this bug. Whereas if you have solid tests, then the bug raises its head immediately, and we can guard against it. Now, you're not going to get everything with unit tests, but you can get a lot of things with unit tests. The downside of the unit tests, obviously, is they take time, and if you're an impatient programmer, you just want to get straight to the code and do something cool, then testing's probably not for you. However, I mean, I see it go both ways. It seems like most professional programmers I talk to know that testing's good. They should write tests, but they never have the time to do it. I have the time to do it here, so I'm going to write tests as much as possible as we flesh out our engine. So I have gtest now. Gtest, okay, so there's the source files, and then here's the header files. So we need to bring them in. Now, where am I going to write my tests? All right, I could write my tests here in my sandbox game, but then it's kind of in the middle of my sandbox, and I'd rather my tests be somewhere else. I could write my tests in my engine, but now tests are going to be part of your engine, and every time you build, you're going to have to. It doesn't make sense to have it in either one of them. So I'm actually going to make a third project just for testing. So let's do that. Right click here, add new project. I'm going to call it, let's see, 3132 console application. I'm going to call it engine test. Oh, not texter, tester. Alright, and click OK. Next. No precompiled headers. Again, I'm going to delete all the trash I feel that they put in here. Delete, don't remove. Get rid of these virtual folders. Bring this out here. Let's call it. It's hung. Visual Studio's hung. Let me pause the video and wait for it. Okay, I think we're back. F2. Let's call it my main.cpp. If I can spell main. Oh, that's terrible. My main.cpp. I no longer need this filter, so I'm going to delete that. Nice and clean. And again, void main. Don't choke when I do this. Build started. Build succeeded. Okay, I'm good. I'm gonna check this in. I'm gonna check in everything because we added a new project to the sandbox game. I'm gonna go check this in. Okay, so I'm just committed now. Let me get gtest back on the screen here. All right, so there's source and then there's the header files here. So here's all the headers. This is the include for gtest, and then here's the source files. Now you may think, oh no, I need to add all these CC files into my project. But if you look at this, the way they've designed this gtest, if I can just add this CC, which is a compilation units, like our CPP files, if I can just add that, let's look at what they did here. Copyright 2008, go down, Oh, look at this. gtest dash all this compilation unit pound includes all the other compilation units, making one big fat compilation unit. So we can take that approach, or we could take the approach where we don't do this and we just have all these compilation units be part of our project. I'm going to go with this leaner, I think a little cleaner way of doing it. So let me show you how to set this up. First thing, as always, we need to set up the include portion of gtest here. So now, I'll also go back. Let me look at this. gtest is a little bit special. Remember glue, we had bin include lib. Qt, we had bin include lib. With gtest, instead we have just gtest and source. There's no lib, there's no bin, it's not compiled. I could compile it via make another project and that sort of thing. I don't want to do that. Let's just, for purposes, we'll just use it in our engine tester. So let me bring up that gtest all file again. Sorry, I'm all over the place here. Where is gtest all? Sorry, it's a compilation unit. It's not a header file. Look at the way they're pound including here. They're saying source slash source slash source slash source slash. And if I bring up a header file, let's pick any of these. I don't know, gtest. How about that? And you notice we got gtest slash. These are all the header files that are being included. Okay, gtest slash. So we have to reason about this a little bit and think, well, what does our include path need to be? Right? You might think that it needs to be this gtest folder because that's where the header files are, but on the contrary, they go in, and their includes, they go into gtest for us. So we need to come back up one. And remember the source, well, if I go back to gtest -all, it's source slash. Alright, so source slash. So this folder here needs to be our include path. So let's do that. I'm going to right click engine tester. And let's actually, while I'm at it, set this as the startup project. Notice it changes to bold there. Then properties, C++, general, additional include directories. And I believe we were using project_dir. It's project_dir. Go up one directory, go into middleware, then go into gtest, and that's it. Enter. Alright, and then one other thing, I need to add this gtest all.cc. I need to add it to my project here because I need to compile something. So let's add this gtest all.cc to our project here so it actually will build. So let me add existing item, engine tester, project files, middleware, gtest, source, gtest all, boom, and it's there. I'm going to actually close that off. So we're back to main. If I double click this, I just want to prove something here that if I hit file save as, it shows me that we added this compilation unit, gtest all. We added it directly into our project. We didn't copy it into our project directory at all. We added this. So when we tell it to compile, it's going to compile this gtest all in within. It'll still go to the temporary folder for our project, but the actual file is still sitting with all of its buddies out there in middleware land. Let's build. Control-Shift-B. Build started. Build succeeded. We're good. So let's see if we can write a test.